Welcome to this Java tutorial based on the concept, class as the basis of all computations. In object-oriented programming, a class acts as a foundation for organizing data and behavior. Through this approach, we learn how to build programs that closely resemble real-world entities. In this lesson, we'll use a class named rectangle to compute its area, perimeter, and diagonal, demonstrating how powerful and organized class-based programming can be. Let's now take a look at the problem statement. We are required to design a Java class called rectangle that represents the basic properties and computations related to a rectangle. The class should include two instance variables, length and breadth, both of type int. These variables will store the dimensions of the rectangle. In addition to the variables, the class must include three member methods. The first method, inputdata, will take input for length and breadth from the user using a scanner. The second method, calculate, will perform the actual computations. It will calculate the area by multiplying length and breadth. The perimeter using the formula 2 times length plus breadth, and the diagonal using the Pythagorean theorem, square root of the sum of squares of length and breadth. The third method, outputdata, will display the calculated area, perimeter, and diagonal to the user in a readable format. In short, the objective is to apply the concepts of class design, method definition, and mathematical operations, all wrapped into a real-world scenario, a rectangle. Here's the algorithm. We start by defining a class with necessary variables and methods. The user provides length and breadth. Then, we calculate area, perimeter, and diagonal using formulas and display the results. Let's take a closer look at the first method in our rectangle class, the inputdata method. This method is responsible for accepting input values for the rectangle's length and breadth. We'll begin by creating a scanner object, named SC. The scanner class is part of Java's utility package, and it allows us to read input from the keyboard. Next, we use system.out.print to display a prompt asking the user to enter the length of the rectangle. The value entered by the user is read using sc.nextInt and stored in the instance variable length. We then repeat the same process for the breadth. The user is prompted again, and the value entered is stored in the breadth variable. This method ensures that both the required dimensions of the rectangle are collected before any calculations begin. By separating input logic into its own method, the program becomes more modular, easy to maintain, and clearly organized, all of which are best practices in object-oriented programming. Now let's move on to the most important part of the rectangle class, the calculate method. This method handles all the computations required to analyze the properties of a rectangle. First, we calculate the area of the rectangle. The formula is simple, length multiplied by breadth. This value is stored in the area variable. Next, we compute the perimeter. The perimeter of a rectangle is given by 2 times the sum of its length and breadth, represented by the formula 2 times length plus breadth. This value is stored in the perimeter variable. Finally, we calculate the diagonal of the rectangle. According to the Pythagorean theorem, the diagonal is the square root of the sum of the squares of the length and the breadth. In Java, we use the built-in function math.sqrt to compute the square root. The result is stored in the diagonal variable, which is of type double to handle decimal values. By using this method, we neatly separate all computations from input and output, which makes our code easier to debug, test, and reuse. The method captures the core mathematical logics behind a rectangle in a clean, organized way. Now that we've performed all the calculations, it's time to display the results to the user. This is done in the outputdata method. This method uses system.out.println to print the area and perimeter of the rectangle. These are integer values and are displayed directly. For the diagonal, which is a decimal or floating point number, we use system.out.print. This function allows us to control the formatting of the output. In our case, we use %.2f, which ensures that the diagonal is shown with exactly 2 digits after the decimal point. This improves readability and presents the result in a professional, clear format. This method provides a clean separation between the logic of computation and presentation. It helps keep the display code organized and ensures that users see well-formatted results without needing to understand the internal calculations. Now let's take a look at how the entire program comes together in a structured and organized manner. We start by defining the class rectangle, which contains both data members and member methods. The variables length, breadth, area, perimeter, and diagonal are declared at the class level, so they are accessible to all methods within the class. 3 methods follow. InputData handles the input from the user. Calculate performs the mathematical operations. And outputData displays the results. These methods make the program modular, meaning each method is responsible for just one task. This improves readability and makes future debugging or changes easier. In the main method, we create an object named obj from the rectangle class. Then, using this object, we call the 3 methods in order. First, InputData is called to gather input. Then, calculate processes that data. Finally, outputData displays the output to the user. This approach highlights the essence of object-oriented programming, combining data and behavior inside reusable class structures. It also shows how encapsulation and method abstraction help organize logic cleanly and logically. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. In this slide, we take a deeper look at the data that flows through the program using a variable description table, or VDT. This table helps us understand the role of each variable used in the rectangle class. The first 2 variables, length and breadth, are both integers. These store the dimensions of the rectangle as entered by the user. Next, we have area and perimeter, also of type int. These variables are used to hold the computed values of the rectangle's area and perimeter, which are always whole numbers if the inputs are integers. Finally, we have the diagonal, which is of type double. This is because the diagonal is calculated using the square root of the sum of squares, which can often result in a decimal value. Choosing the right data type here is important to ensure mathematical accuracy and precision. Using a VDT like this helps students and programmers alike to quickly identify what each variable is used for and how it contributes to the program's functionality. Let's now look at a sample run of the program to understand how all the components work together. The program begins by prompting the user for input. Here, the user enters the length of the rectangle as 6 and the breadth as 8. Once the input is provided, the program moves on to the calculate method and performs the computations. The area is calculated as 6 multiplied by 8, which equals 48. The perimeter is calculated as 2 times the sum of 6 and 8, giving us 28. The diagonal is calculated using the formula, square root of 6 squared plus 8 squared, which results in a value of 10.00. The program uses system.out.print to format this result to exactly 2 decimal places. This output confirms that our program is working as expected. It accurately accepts input, performs precise calculations, and presents the results in a clear, user-friendly manner. Let's now take a moment to recap everything we've learned in this lesson and highlight some key points that you should remember. We started by understanding how to create a class in Java, in our case, a class named rectangle. Inside this class, we used instance variables to store the properties of a rectangle, its length, breadth, area, perimeter, and diagonal. We then wrote 3 well-structured methods, one for taking input, another for performing calculations, and a third for displaying results. Each method was clearly separated in its purpose, showcasing a modular design, a core principle in clean coding. We also used Java's built-in methods such as math.sqrt for mathematical calculations and system.out.print for displaying decimals precisely, formatted to 2 decimal places. Most importantly, this program reinforced the structure and philosophy of object-oriented programming, where we organize both data and behavior into reusable components called classes. Now, here are the key points to take away. Always define a class for real-world objects you are modeling. Split your logic into clear methods, such as input, process, and output. Use appropriate data types, for example, double for values that require decimals. Keep variable names descriptive and meaningful. And lastly, focus on formatting your output for clarity, a small touch that makes a big difference in user experience. This structured and clean approach not only helps in scoring better in exams but also builds a strong foundation for professional coding in the future. Thank you so much for watching this session on class as the basis of all computations using Java. I hope the explanation made the concept clearer and more enjoyable for you. All the important components, the question, algorithm, Java program, variable table, and output, are available in the description box below. If you found this lesson helpful, don't forget to like, share it with your classmates, and subscribe for more easy-to-follow programming tutorials. Every share and comment encourages more students to learn with clarity and confidence. Keep practicing, keep building, and remember, your journey to becoming a great programmer starts with mastering the basics. See you in the next session, and as always, happy coding.